Welcome to this video. In this example, I'm going to show you an optimization using GRSM algorithm. For this video, I'm using an ARM model. Here in define input, we're going to clear radius 1, 2, and 3 because this one have been identified as unimportant parameters, so we can screen them out. Now, in define output responses, the optimization objective is going to be to reduce volume while respecting a constraint on max displacement that should be less than 1.5 millimeters. In specifications, we are going to select GRSM, which is an algorithm used for creating a global approximation model to predict the behavior of a system based on a limited set of input and output data. It constructs a global response surface by combining data from multiple regions of the design space to capture the complex interactions between the input and output variables. So this allows for a faster and more efficient exploration of the design space during optimization. The recommendation here is to use GRSM with the default settings because they work optimally with most of the cases. So we're going to click apply and then we are going to evaluate the task. Here it is important to see how it progresses. We can see how the parameters are changing in their bounds. In every parameter, the variations are shown within the bounds. We want to see if we have reached the minimum or the maximum bounds for some of the parameters. So this information it is important because in case we haven't found a solution, this can be the reason. So maybe a solution can be to extend the bounds. We can also see how the optimization functions are changing. If the solution is good, you can stop here, but if it isn't, you can continue the optimization by copying the first optimization. Here we are going to extend some of the bounds to relax them and see if we find a better solution. Now, in specifications, we are going to use as inclusion matrix the first GRSM optimization. We are going to click apply, and then we are going to evaluate the task. As you can see, the 50 evaluations from the previous optimization are here. Here we want to see if there is a better solution, so as you can see, the best solution found previously is the first solution for the first iteration of the second GRSM. And we have found a better solution. A quick recap here is that GRSM is the most general purpose algorithm in HyperStudy because it explores the design space globally while requiring few evaluations. The recommendation here is to use GRSM with the default settings and then observe the systems for improvement. If it is enough, in your case, there is no reason to add more evaluation. But if it isn't, you can start a second GRSM from the best solution found in the first one using an inclusion matrix. This process could be repeated as many times as you want. Finally, a tip here is to observe inputs versus iterations. If bounds are reached and if it is possible to relax them, you can run a second optimization with new bounds to search for a better solution, which is what we did here. Don't forget that if you change your bounds, you can still use the previously run data as an inclusion. The information from those points is still valid even if the optimization formulation has changed. This is why we sometimes refer to inclusion as a recycling data. It is more than a restart. Thank you for watching this video.